Hello, I'm Patrick. We're doing an Android testing tools overview tonight. I've given this presentation before in kind of a different format, probably 3 or 4 years ago, but the testing ecosystem has changed kind of significantly, like year after year. I'm happy to say it's gotten better year after year. So this is going to be, I think, an interesting presentation. I've been developing for longer than I would like to admit now, but not terribly long. At least Android for 6 years, since kind of 2.0, 2.1 came out with the original Moto Droid. I'm a co-organizer here along with Greg and co-founder at Atomic Robot. I like pizza and barbecue and beer and bourbon and nachos and all the things I shouldn't have, and I don't sleep a whole lot. So let's talk about the plan for tonight. I'm going to go over some goals and expectations, kind of the things I'd like to make sure we get covered tonight, and what we're going to talk about and what we're not going to talk about, because there's a lot of stuff to cover, and I don't want to keep everyone here until like 2 in the morning. I don't think you'd like that. The motivation for kind of why we're talking about some of this stuff. There's a lot of things to talk about, so kind of creating like a roadmap of here's what everything is and how to navigate it and how they all kind of fit together and complement each other. And then lots of links, and then time for questions. Sound good? Cool. I do have a lot of sample code for this. I've got it up on GitHub. I've got everything kind of tagged as we kind of go through the presentation. So if you want to see the evolution of how do I bring it or go from this library to this library and what are the differences, you can kind of do a diff between the different tags. And I'll post a link to the presentation along with all these other links up on the Meetup site at the end of the night. So goals and expectations. Like I said, there's a lot of different tools in the testing ecosystem. It can be really intimidating the first time you look at them, saying, okay, how do I make sense of all this? What do I use where? What doesn't work? What does this frickin' exception mean? So I want to try to help minimize the barrier to entry and increase the awareness of what's available and where they fit together. It's always fun to see things actually running inside of a tool. We're going to hope that the demo gods are favorable tonight. I can't promise that, but we'll see. I did pull down the new version of Android Studio a few days ago, and I haven't actually done a dry run with the new version, so fingers crossed. We're going to show how everything kind of relates to each other, builds upon each other, just again to kind of minimize that barrier of entry, saying, okay, this isn't as complex or intimidating as it could have been. And then I want everyone to be able to leave with tools that they can bring into their own applications. We're not going to have time to go into depth with any of these things. Each of these tools I could probably talk about for at least 2 hours. And again, I don't think you want to stay here until 5 in the morning. It keeps getting later. We're not going to cover all the available tools. It's a big ecosystem. It's changing all the time. These are just kind of the core ones, and I think the ones that are especially useful. And it's not going to solve all your problems, and it might actually create new ones. So we'll see. So why are we here? Automated testing is one of these really cool things that's kind of counterintuitive. You end up spending a lot of time creating these tests that might test 5 or 6 lines of code. And you're like, okay, so why did I just spend this time when I could have just been done? It lets you continue to deliver value and quality in your application over time, continuously. I mean, as you find a new bug, write a test around it. And that way, the next time you ship your application, you're not going to ship that same bug. The things that might take 10 or 15 minutes to do manual testing on, you can kind of skip. Let the computer do this for you. So there's a lot of value in it, and it's an investment that you're making into what you're building. Okay, lots of thumbs up, cool. So investing, change, value, these aren't technical terms, these are business terms. So as you're talking to your product owners and your managers about why this is important, you can kind of communicate this in the context of a business sense. It's we're not going to ship crap if we spend this extra time doing this. We're going to be able to ship higher quality apps continuously over time if we continue to do this. So again, it's an investment. You need to have a discussion with it. And how how will adding tests help me work smarter? Who creates Android applications? Who tests their Android applications? Who tests their Android applications like this? Who thinks that is really frickin' slow? Yes. What if you could free up hours of your day and calculate that across months and weeks? What else could you be doing with that?
More coding.
Yes. Writing more tests. No. Over time, it does help you, do things faster. You're not going to be going through and spending 2 days making sure that everything in your app works across all of these weird scenarios, hoping you don't miss some use case or some test setup or whatever. You can't eliminate having thumbs on screens. It's just not practical, but you can at least try to minimize it. It helps create confidence that what you're going to ship is good. When you have your build server go through and generate your application and it's run 10,000 tests, you can push it to Google Play and go home and not be up at 2 in the morning. That feels really good. So less bugs, happier users. And are you doing it wrong if you don't have automated tests? No. Just kind of be pragmatic and intelligent about where you're doing them. If things are constantly changing on your project, it might be more valuable just to get the code done and test it in front of actual users to see if it offers value, because you might end up deleting it. So, instead of over-investing in unit tests. But if you've got a code base that you're going to be maintaining for 3.5 years, you writing tests now, looking 3.5 years in the future, that guy's going to thank you. So, again, be pragmatic. Know where you're at, know what the needs are. So, any questions so far? Okay. So all of the tools. So we're going to work against kind of this really simple app tonight. It's a calculator app. You give it 2 numbers, and it adds them together. This screenshot doesn't show it, but the actual application has a thing where you can actually go pass the 2 numbers into Google, and it'll fact check your addition. And we're going to write tests around all of this tonight. The app is maybe 150 lines of code. It's not anything fancy, but it'll let us kind of explore the different tools and how they fit in and what you can do with them. So some of the requirements of the app, if either side of the equation is blank, if you don't want to put something in, we don't want to show a sum. If they put in 2 letters, we don't want to add those together. If they do put in 2 numbers, 2 and 2, we want to show 4. And we also want to be able to check the correctness of it. Hand our equation off to someone else to say, do these 2 numbers really, show me the results. Because addition is hard to get, or easy to get wrong. So where do we start? Who has been out to the developer site and looked at all the Android testing tools that are available? No one. Okay. When you go there, it looks a lot like this. You just really don't know where to start. So we're going to address that tonight. So this is the path we're going to take. We're going to start off with this tool called JUnit and kind of build upon it. And we'll kind of work through examples of how do you build up a really simple JUnit test? How do you run it? How do you build upon that? Where does it fall down? Where do you go to the next thing? And we're going to look at some of the newer tools they built into Android Studio and released as products that we can start taking advantage of today. If you kind of look at this, I've got it color-coded between blue and green and this pinkish, orange, red color. The things that are blue, you want to write more of. The things that are kind of some of those early green things on that path, you want to write a little bit less of those. And the things that are farther on the green path, you want to write even kind of less of those. And then the finger emoji, you want to try to do as little of that as possible. This is kind of, you might hear of a test pyramid if you talk to someone who does a lot of this. This is kind of that, you want to do more stuff at the bottom, less stuff at the top. A little bit more about that diagram. The things that are in the blue are tools that don't require an actual physical device or an emulator to run tests on. You know, they run straight on your computer. That code is going to live in one folder in your project. The things in green actually do require an emulator or a physical device, and those are going to live in another folder. And they will actually run on a device. And then the thing on the side is a cloud service that we'll kind of look at that Google started offering. So if you don't have actual devices, you can run it on theirs. Any questions so far? Okay. Let's take a look at JUnit. Who has done Java development? Okay, almost everyone raised their hand. Who has used JUnit in their projects? Okay, about 2/3. Okay, so JUnit is kind of like the de facto standard core unit testing framework for Java projects. It's pretty simple to get going. It's well documented. Almost everyone in the community uses it, and it's a first-class citizen with Android projects. So let's take a look at what that looks like. If you wanted to add it to your app in your Gradle file, it's a one-liner. Let me turn on this thing. You basically add that line to your dependencies, and now you have JUnit in your project and available. The really nice thing is that if you're creating a new project, at least recently with Android Studio, it's already there. You don't have to do anything. Your project already has JUnit in it. Yay! All your tests are going to live in a source test Java directory, and we'll take a look at that. So let's write a simple JUnit test to make sure our calculator handles addition. So let me run this. Let's take a look at our app. So here's our application. Does 2 plus 2 equal 4? Cool. So our activity code, like I said, is under 100 lines long, nothing really glorious. And we have a calculator that takes in, one method takes in 2 strings and the other one takes in 2 ints. The one that takes in 2 strings does some comparison around, is it empty? Can I parse it? And if not, then do everything else. So let's write a test to make sure that addition of 2 integers works. What you can do is go to the top of your class, way up here. If you right-click or Command N, nope. Option N, nope. Oh, Option Enter. Yeah, hit Option Enter. It even gives you a nice helper method or helper action to say, hey, I want to create a test for this. I want to create a JUnit 4 test, and I want to call it calculator test. That's kind of the naming convention. The class under test, you follow up with test. And it makes it really easy to navigate things and see how things are related. And I want to test this addition method for 2 ints. And let's hit OK. And I said that things in the blue, the JUnit tests, we want to put inside of the app source main test or app source test Java folder. So we're going to pick the second option. Hit OK. And sure. So let's do this. We're going to create our calculator object. We're going to add 2 numbers. And we want to assert, basically verify, that what we got out of our calculator is correct. So we're going to do assert equals 4 and some. Cool. That is our first JUnit test. If you want to run it, you go up here, right-click, and hit Run Calculator Test, or figure out what those hieroglyphics are and use the keyboard shortcut. So when you do that, what it's going to do is it's going to build the code you just wrote, your calculator code. It's going to then execute it or call all of that code with this calculator tests code. So this is how you can basically make sure that the stuff you wrote is doing kind of what you expect. You're going to do a little bit of setup. You're going to do some behavior against it, and then make sure that what it did is kind of what you expect. So let's go a little bit farther. We'll even call this, add ints. Let's create another test. We're going to do add empty string. Let's create another calculator. And per our requirements that we listed earlier, if you give it an empty string, we expect an empty string to come back. So we're going to do assert equals, if I can type, and then let's run our test again. That's interesting. Why did it fail? Yes. So unit testing in Android projects is awesome until you get this error. Method whatever in whatever class is not mocked. So if we take a look at this, add method, we're making use of this class in here called textdoodles, which is coming off of the Android code base, Android API, which when you're running it on your machine, you don't have access to, like a real implementation of it. They give you everything, but it's all stubbed out to not do anything. There's kind of an easy solution to this. There's a tool called Robolectric. This is not a tool provided by Google, but it fills a gap that they've kind of left with the Android testing ecosystem. When you run into something like this. What they've done is they've kind of created shims of the Android APIs that you can load in at runtime in your tests. Then it gets handled automatically for you. So that way you don't get that nasty method not stubbed exception. It also lets you access things like if you're making reference to strings via a context, like a r.string.appName or whatever. In a pure JUnit test, that wouldn't resolve anything. It would just, blow up with one of these, method is not stubbed or not mocked errors. This will actually go through and it knows how to parse everything and load it up. So when you say, give me string, r.string.appName, it'll turn it into whatever you actually have in your project without needing to run all the stuff on a device. It's not perfect because, they're approximations of a version of Android. So if the behavior of this was different on one OS version versus another, you're not going to catch that. But it does a pretty good job at what it does. If you want, the other way to get around this is just not put your tests in source test Java, just put them in source test Android. It takes a little bit longer to run, and we'll talk about that in a second, but then you're actually running Android code on an Android device or emulator. So kind of figure out what works best for you. So let's take a look at what it takes to add this into our project. We've got a new compile dependency we want to pull in. Yeah?
How much of the SDK do they have in Roboelectric? Is it only certain portions of it or most of it?
The useful parts?
Okay.
Yeah, the useful parts. That's a clever way of saying I'm not entirely sure what all. It's kind of grows over time.
Okay. Also, in the test, we use test utils to check if the string is empty. How do you not just use the string that is empty?
The string that is empty, I don't think checks for null values. Textdoodles does.
It'll throw a null pointer
Yeah.
exception if you run
Okay.
on the string.
you might think about another method that Android provides, like one of its regular expression things for pattern matching, like an email address or something. That's something that they're going to provide with Roboelectric that you're not going to get otherwise. So, yeah, this was kind of a engineered scenario just to make sure that text doodles is something that we kind of use in all of our projects, and so it's a easy thing to run into. So going back to the Roboelectric, you add one thing to your Gradle file, you'll end up creating this other properties file that includes your project name, what SDK you want to target or you want Roboelectric to kind of emulate. Your tests go all in the same place. You do have to change your project or your unit test with a new annotation up top, and that did not format well, so we'll take a look at it. And I'm going to cheat. We're going to revert all of these. I don't want to copy and paste all that stuff. Cool. Let's hit sync now because we changed our Gradle file. So just to kind of show you, here is Roboelectric in our project file. If we go to source, test, resources, here's the new file that we created. And our Roboelectric test, here's the annotation that we had to put at the top of it. And what this does is it tells the tooling that's running all the JUnit tests that I want kind of a different behavior. I want something else to be running this than what you provide by default. In this case, we're saying I want Roboelectric to have its runner to get a chance to do things, so that way it can load in everything it needs before our actual test run. So instead of getting the stubbed exception we got before, we'll actually get a implementation of text doodles. Running it is all the same thing. You right click on it and you hit run. Oh, crap. What did I do?
Your config file had git 1.21.
Not anymore, doesn't it? Okay. So what you'll notice is that our tests don't run quite as fast. A cost of Roboelectric is it takes a little bit of time to get everything all loaded up and swap out those stub implementations with a real implementation. But it still runs a lot faster than needing to package up your application, deploy that to a device, package up your test application, deploy that device, wait for it to run, wait for it to give feedback. So still a tighter feedback cycle. And then you're not creating awkward production code. You're actually able to use sane things that you would actually use otherwise. Any questions so far? Cool. This is all kind of making sense on how they fit together, at least these first two. Cool. So these are all tests that run on your computer, excluding the emulator. They're not going to run on a device. Let's take a look at our next one. Okay, we went to the live coding. Now we're going to dig into instrumented tests. These are where we're going to start building upon things that are actually going to run on devices. And if we kind of remember back from our testing pyramid earlier, you kind of want to be wanting to write fewer of these for your project. They take longer to run. They're going to occasionally be a little more fragile. I've got a closet full of old devices that I'm kind of constantly tweaking and maintaining, and things will run one day and then fail the next, and so yeah, they're not perfect, but they're still really good. They've got a few different ways you can set up different actual Android components to run. We're going to look at how do you test an activity. And again, everything from here on out is going to live inside of the Android test folder. They get packaged and run differently. And Google has a handful of the documentation around what you can do with Android tests or instrumented tests, and Espresso and uiautomator is getting better, especially over the last year. They've you can tell they've spent some time with it. So there are lots of good resources out there. So the things we have to do, a few more steps this time than what we did when we added in Roboelectric. Still in your config file, you have to specify that you want a different, you want Android to use a different JUnit runner. And what this will do is it knows how to process the newer way of writing JUnit tests, and it does a few other things for you too. You'll want to pull in a few extra dependencies. And at least as of the 0.5 version of these, you've got to do some, if you're also pulling in the support library to your application, you've got to do this other hack to make things actually compile and build and work. I don't know why. It's been like this for a few versions now. This seems to work. So we're going to write a test that that's going to start up an activity, and we want to make sure that the title that's displayed up top, I think where it said calculator, actually says calculator. And because I don't want to type all this out again, we're going to revert. Cool. Sync our Gradle project because we pulled in new dependencies. Oh. Well, okay, we're done with Robolectric, so it doesn't matter anyway. So let's look at our Gradle project. So here's where we pulled in our 2 new dependencies. Pulled in our hack for the configuration stuff, and then our Android block up here. We're specifying our JUnit Android runner. So pretty easy stuff to get set up. We're going to close out over here. Now we're going to jump over to this project. So this should look pretty familiar. We've got a test or a class called main activity test. Guess what it tests? The main activity. We're going to use this activity test rule, which is the new way that Android wants you to do instrumented tests. There's an older way where they've got like 2 versions of these, like activity test class and activity test class 2, because the first one wasn't good enough, and now we've got this new way. So things are getting better every year. So you basically set all this up. It's a long line you have to do once, and you basically say, I want to test the main activity. What this will do is that when every test method gets executed, so whenever it tries to run this, right beforehand, it'll actually go through and start up your activity and wait for it to finish on resume, and then jump into your method. So it'll actually run you through that entire life cycle. So we're going to call this activity rule, get a reference to the activity that's being run, and say, give me the title. What are you showing up on the top of the screen? Does it say testing presentation? This test should actually fail, but let's take a look. Let's do run main activity test. So you do that, and now we've got something a little bit different. It's going to prompt you to pick a device to deploy to. You can pick, if you've got a handful of devices plugged in, you can do like a Control-A, select all, and have it run it across a handful of devices all at once. Pretty cool. Let's hit OK. So what it's going to do behind the scenes is it's going to package up your application, deploy it to the emulator or device, package up your testing stuff as its own application, deploy that to the device, and then tell the testing application, go ahead and run and interact with your application. So it takes a little bit longer to run because it's doing more stuff. And as your application and test suite get bigger and bigger, this gets slower and slower. It's a side effect. Go ahead.
In my experience, if you have a whole lot of instrumentation tests, most of the time that it takes to actually run through the test is spent spinning up the app, not running an instrumentation test. So it's, I don't know, people always say it's really slow, especially on these newer emulators. It's
The newer emulators have done tons to make this bearable. 2 or even 3 years ago, there's a reason that Roboelectric exists, because people didn't want to actually go through this process. It solved a real problem. This one, running all the tests took 328 milliseconds. That's pretty bearable. Yeah, it's trying to find the right place to put things can be a interesting dilemma or debate sometimes. It's definitely better than it used to be. So what you noticed is that it ran all of this. And did anyone see the screen over here flicker? How long did it take it to check that the title was correct?
328 milliseconds.
Yeah, a little bit less than that, but yeah. How long would it take you to go through, open up the app, and then read the title to make sure that that's correct after you've found where you're at and your written out test plan to make sure that you go through these steps and then make sure that this happens.
At least 329.
Yeah, at least 329 milliseconds. Yeah, so so this is an interesting way of interacting with actual things that are running inside your app, kind of in a more isolated manner. Any questions on this? Cool. So let's jump into Espresso. And I'll start this off with, I kind of have a love-hate relationship with Espresso. It lets you write tests that interact with your application in a way that are really more readable without needing to add in all these extra test hooks into your production code. The tests that you write, still kind of build upon what we had before. They've still got the activity test rule up top because you still have to have an activity that you're going to be testing. It's just a way of doing assertions across what's actually being displayed on the screen. It's gotten a lot better this last year. We now have an Espresso test recorder inside of Android Studio that makes not writing Espresso tests less of an excuse. It's still in development. There are still bugs with it. It's not perfect. The code that it generates isn't necessarily the stuff that I would write, but because it does it for free and I don't have to necessarily go through and write it out myself, it's good enough for me. And then they have lots of docs around all this new stuff. So that's the light side of Espresso. The downside to Espresso, if there are dialogues or windows or anything else that pop up on top of your app, your test is probably going to die. A case of this might be you've got a Samsung application that all of a sudden force closed in the background at 9 o'clock at night after you're home. All of your Espresso tests are going to continue to fail until you come in the next day and hit OK to close out the force close dialog. That's really annoying. Another fun one, if your app has an indeterminate progress bar and you're on 5.0 and above, the progress bar that kind of spins circles, what that does is it runs a continuous animation loop on the main thread of your application that prevents Espresso from moving forward. Espresso is going to wait for this quiet time in your application to start running its assertions. It's never going to get that. And then for every test, it's going to sit there and wait for 45 seconds and before it finally gives up. That's really annoying. If your device has animations turned on, like screen transitions, your test might fail. And then just sometimes if the stars aren't aligned right, your tests are going to fail. You rerun it again, and then it'll work. All of that said, there's still value in this because you can validate the state of your UI, and these things you can work around, and the times that they happen are the exceptions. So I will take having a suite of tests that build confidence in my code to deal with the Samsung crash where I come in the next day and hit, okay, I understand that the email emoji service crashed. Okay, cool. True story about the Samsung app. I can't remember what the service was, but yeah, go ahead.
Hey, so what do you do to fix the animation issue?
To fix the animation issue, if you have what you can do is go to your device settings. If your device settings are working.
I'm sorry, the indeterminate progress.
You set the visibility to gone. I don't have a really good solution for it, and everything I found doesn't meet my expectations for what I would consider a good solution. So
So if the espresso test is the type of instrumentation test, wouldn't you be able to, say, set the visibility to go on beforehand, like in the add before?
yep. So you can see, you can basically say before I start running all these espresso assertions, go through and turn the progress indicator to invisible, which is, I don't like this solution because now you've got kind of these other hooks into your production code to manage state, but it's a hack. What do you say?
Themes. Themes would be a really good way to do it.
Okay.
Because you can have different builds for your instrumentation and your espresso test. You can have different build targets, should I say.
Mm-hmm.
And if you have a theme override for all the indeterminate progress bars as you've gone, then your issue solved throughout that.
Very quickly too. I like that. So yes, what he said.
You have like actual code in your activity or fragment that says turn the indeterminate progress bar on,
Yep.
or set its view, set that view to visible, then you're overriding it.
Yep. So, yeah, themes. I'll have to try that. Does it work well?
I don't know, I just thought about it.
Oh, okay. So we got something to try.
So do you have to worry about many false positives with this? It looks like all the times it fails when it shouldn't have. Is there any time when it fails to declare something that went wrong?
I'm not sure I follow.
So these are all times where it's saying it failed when it shouldn't have.
Yep.
Does Espresso have a problem of saying that it failed when it didn't fail? Or when it's saying that it didn't fail when it did fail?
Not that I've seen.
Typically on this, if it is the way that you program your test to be, then it passes it. And if anything else happens, then it's.
So adding Espresso into your app is just a one-liner after everything else we've done. Just another Android test compile dependency. And because I'm still going to cheat, we're going to jump over to that tag. And let's go ahead and sync up our Gradle project. So here's our new file, or new dependency we've added in. And let's take a look at this. So we've got our main activity. My convention is if you're writing an Espresso test, just write an Espresso test at the end, just so that way you kind of understand a little bit more about what it's doing and why. You don't have to. You could put them all in the same file. I think it just makes things easier to understand a little bit more about what's under context or under test. The things that are going to be in Espresso are more view level assertions. So let's take a look at this. So this looks like code that they generated. So we're going to delete this, and we're going to use the new Espresso test recorder in Android Studio to write our first Espresso test. You go up to Run, and then Record Espresso Test. Same type of thing. It's going to ask what device you want to run it on, and you hit OK. And this is where I'm hoping the demo gods play nicely. So it'll take a second to run as it packages up your application and the test APK and starts up the Espresso test recorder. And the
You're not using beta software.
I am beta software.
Oh.
Yeah. I like to live on the edge. So let's do this. We're going to hit 2, and you'll notice that our interactions with the app are really, really slow now. But it's also recording all the interactions we're doing. I'm going to go over to this field and type in 2. So it knows that in my left field I put into, in my right field I put into. It'd be really nice to make sure that that's set 4. So let's hit add assertion. It'll go through and grab all of the views on the screen and pull them over onto the side where you can interact with them. So, you can like just basically point and click and say, this view, I'm going to zoom in down here. I want to edit the assertion that the field that has an ID with a name of sum, that the text is equal to 4, and hit save assertion. That's pretty cool. And then let's hit complete recording. We're just going to call this main activity Espresso test, and hit save. So what it generates is all the code that we would have saw before, plus some new stuff. Things have changed in the last version. All of this is stuff you could probably factor down into quite a bit less code. For putting something into the left field, I would probably actually write on view with ID RID left dot perform replace text and put into. So this is what they generate, and this is what a sane person would generate or write. But I didn't have to write, well, I wrote this, but I'm not going to have to write the other stuff. So this is still beta software. If you wanted to create another test to validate something else, it won't add it to this file. It'll want to create another file, which is kind of annoying. So you end up with kind of this extra file that you keep pulling these generated methods out of and pulling them back into here. You might go through and kind of refactor some of the code that it generates. But this is still insanely more efficient than going through and writing out all this, and it's something that anyone can do. It's literally point and click. Go ahead.
Like, so I take it you don't find it that practical to, I guess, write a lot of this, or is it like completely?
It depends, and it depends on what your test is doing. For a calculator thing like this, I would just probably write it out. For demoing it and for more complex UIs, where you might have views in different conditional states, this is going to be pretty good about understanding what states things are in and understanding that it needs to match all of these criteria for it to be able to operate on that view. Let's try something. So we're going to do on view with ID left and on view with ID right. We're going to get rid of some of this stuff. And we're going to get rid of this. So we're going to say, basically, we'll do on view with ID, RID sum, check matches with text and 4. We'll get rid of all that crap too. And get rid of all that crap that it generated. I swear it's a good thing. So if we run this, it's going to run really fast, and we'll just see a screen flicker over here. Start with the generated code and then refactor to the readable code. So who saw the screen flicker up there? Yeah, it just there and gone really quickly. Something I find useful, throw a breakpoint in it, hit OK. Just if you want to make sure that certain things are happening. Like I want to make sure that 2 and 2 actually got put into the UI.
Flip that 4 to a 5. I don't believe you.
If you want to see it fail, that'd be sad. So when things fail, and this is a fairly tame exception, they get bigger. It'll basically say, hey, on this view that you told me about, the sum field, I was expecting a value of 5 and I didn't find it. But here are all the attributes that you might be interested in. And for text views, go all the way to the far side. And they're usually somewhere over here towards the end. Oh, text equals 4. There you go. Yeah, all the way at the end.
It's a good thing that they're in alphabetical order.
I know.
I'm joking.
Yep. This tooling is getting better all the time. A year ago, this was still really rough. The tests would fail more frequently for like random reasons. You know, writing out more complex tests was just a pain, and it's getting better. So this is a easy introduction to starting to write UI tests in Android. Any questions on this so far? Espresso is a big API, and it's not always the most intuitive thing to work with. So you'll find yourself kind of creating these helper methods to say, do this, weird, matching thing to find this one view inside of a list thing. What I've started doing is kind of refactoring those out into more generic, helper methods that you can then use other places in your test suite. And then you end up with, pretty concise, readable tests like this without all the extra crap. So like if you look at the onView method, well, that's a bad example. Yeah, to make sure that a piece of text is in an input field, that's all the stuff that it has underneath it. So, I'd rather just write out with text or whatever my helper thing is versus deal with all that. So, and we didn't have to put in any fancy hooks into our production code to make any of this happen either. It was able to traverse our view hierarchy to do all these checks for us. So, pretty cool. No questions? Excellent. Live coding. We already did all our live coding, and it worked. uiautomator. So if you can think about Espresso as testing the things inside of your app, if you kind of like draw a box around it, these are the arrows pointing in on your screen. uiautomator lets you also test the things outside of it. This is more black box style testing and gives you a little more control over the device and what you're testing there. There are some trade-offs. You can't write nearly as fluent, or your tests don't end up looking as fluent as they do with Espresso, just because you're interacting with your application kind of from the outside versus the inside. Does that make sense? It's also limited that you can only run this on Android 4.3 and above. So if you're supporting older devices, there's a way you can say, the min target or min SDK for this test is 19, and it won't run it on older devices. There's a command line tool called uiautomator viewer that if you're writing uiautomator tests, you'll want to become friends with. It makes gathering the state of your UI to get content descriptions and property values really, really fast. You'll also find that if you're writing uiautomator tests, the best way of finding references to views to interact with is by setting the content description, the accessibility attributes on them. Don't set developer text on your views just to make a uiautomator test work, because there are people who actually use the accessibility fields when they're using your app, and if they are on a text field called sum, the 4 at the end, and all of a sudden their screen reader is saying, development summation field from left and right equation, or whatever it is you've got in there, that's not a good thing. Or if it's some cryptic, user or some developer value or field or whatever, make it something that people who have accessibility issues can actually benefit from and query off that. Does that make sense? So again, adding uiautomator to your app is a one-liner. The latest version is actually 2.1.2. They've got a bug in it where it'll occasionally crash your test runner, and I haven't been able to figure out why, but I've had it happen across a few different projects now. So stay away from 2.1.2. Maybe 2.1.3 will be better. So live coding. We're going to add two numbers together, check the results, and make sure that the results are displayed. Let's take a look at that. And I'm going to cheat again. I don't like writing code. So looking down at our Gradle file, here's our new dependency for uiautomator. And kind of following the same convention that we did with Espresso, main activity, automator test. Again, you don't have to do this. I just think it makes things easier. uiautomator doesn't require the activity rule thing like our Espresso and instrumentation tests do. Instrumented tests do, just because it interacts with your device a different way. What I recommend doing is going to their documentation for uiautomator, and they've got a code snippet up top that you can just lift into your project that'll actually go through, get a reference to your device, press the home button, actually launch your device from the application launcher, wait for things to kind of settle down. You don't have to write all this code. Copy and paste is completely adequate. When you do want to start doing assertions, you do most things through this device object that uiautomator gives you. And you're saying, I want to find an object on the screen that has a content description called left. So let's take a look at how it's finding left, because that wasn't something that we were ever showing on our UI. So if we go to our layout file, and this is kind of what we saw before, the some field plus some field equals whatever. This is what the accessibility tools use when they're figuring out how to describe things to a user. This is also an easy way for uiautomator to integrate or to interact with your app. Saying, I want to find a view with a accessibility name of left. So this matches up with this. So we're going to get the left side of the equation, the right side of the equation, our summation, and then we've also got a check thing down below that will take what we put in and send it off to Google to check. So on our UI object, which is generic, it's not a text view, it's not a button, it's just something. We're going to attempt to set the value to 1. Same thing on the right side. And then we're going to try to get the text that's displayed out of that thing and make sure that it's equal to 2. And then we've also got this button at the bottom that we'll use to kick off something else inside of our app that'll actually go through and run another app or another part of the system. So let's run this. So you'll notice that it didn't run nearly as quickly as Espresso. It took a little bit longer to interact with all the views on the screen. So that's kind of a downside to it. It required us to do a little more work to put in the accessibility content so we could interact with it. A little more work. And while it would be really awesome, because uiautomator lets us test things outside of the application, it does have limits. If you're opening up another application or even your own application and it's got a web view inside of it, uiautomator doesn't have the ability to go into and write queries against things inside of a web view. Espresso actually does, but you might actually be able to write an Espresso test around this. I'm not sure. So if we go back, let's kick off our application again. This is the checkbox that I pressed at the end. So if we do 2 and 2, you click this and it sends you off to Google. So if you need to do things like rotating the device or pressing the volume up or volume down button, or other things, or check that a value is being displayed in the notification bar up top. Espresso can't do that. uiautomator can. What you'll also find is that if you start writing assertions around what you think are common things in the UI shell around your application, they're going to vary by device. Samsung might call this, notification shade, and some Sony device might call it something else. So turn that off. So your mileage may vary. The reason you want to write fewer of these is because the farther up in this test pyramid you get, the more brittle things get, and the more time you're going to spend maintaining everything. So that's Espresso in a nutshell, or uiautomator in a nutshell. Who's heard of Firebase Test Lab? Okay, a few people. Who has actual Android devices? Okay, almost everyone. Who has lots of Android devices? Okay, well, yeah. Hey, I've got a closet of them. But if you don't have lots of Android devices, Google does, and they've exposed those. So as you write all of these tests that you want to run on Android devices, you can push it up to their cloud. So let's take a look at what this looks like. So let's go back to Android Studio. We're going to take all of our tests we wrote before, our instrumented test, our Espresso test, and our uiautomator test, and we're going to run those with Firebase Test Lab. I think 2 years ago, Google announced this cloud test lab at Google I/O, and then nothing happened until this last year. So this is what we have for it. So we're going to run all of these tests. We have this new deployment target, or this new tab when you're running a thing. I want to run all of these tests on Firebase. So you actually have to go through and set up a project with Google or on Firebase. You have to give them your billing information because this isn't a free service, it's pay as you go. Running all 3 of these tests on 12 different device configurations costs about 20 cents. So it's cheaper than buying devices if you're running it all the time, or if you're not running them often. If you're running them all the time, just buy a cheap device. I hear that Kroger sells some pretty nice cool pads. Again, not a free thing, so you have to set up your billing information, set up an actual project. You can go through and pick devices and configurations and OS things you want to run. So we're going to run all of our tests on a Galaxy S4 Mini, a Galaxy Note 2, an LG G3, sure, an HTC One. Nexus is going to run it all. We all have Nexus phones. And
One thing to note too is if you deployed an app to Google Play recently, it doesn't automatically work.
they do something
It
different.
doesn't run your stuff.
Yeah.
It runs
Yep.
kind of like a monkey runner.
Yep. I can show that in a second. So then you hit OK, and hit OK again, and then things get slow. Because it's going to go through, build your application, build your test application, submit them both up to Google. It's going to run through their infrastructure, find all the devices that it can actually run against. This entire process takes about 3 to 5 minutes. I'm not going to make you sit here and watch this run. What we can do is click on this. They give you a web dashboard, so you can see exactly everything that's going on. It's still a very beta, alpha, maybe even piece of software. We tried to run it across all these devices, and it says incompatible device and API level combination, except for the Galaxy S6. That one was apparently okay. I'm not entirely sure why these all failed. It seems to randomly decide that some devices are okay and others aren't. It keeps a record of all the tests that you've run before, in theory. So here's an example of one I ran before, just on 2 different devices. Now the nice thing is it also records video of the device as it's running these tests. I don't know why the video is 2 minutes long to run. Okay, they've trimmed it, so 16 seconds. It'll tell you all of the information about the device before it actually starts running things. You can actually tell it's a Samsung device because you've got the funky launcher and the funky keyboard. And here's where things get fun. They give you, Samsung devices give you 2 different browsers by default. So whenever you want to open up a web link, like to check that 1 + 1 = 2, you're prompted against this. Writing automated tests to deal with this is kind of a pain. So this is where things kind of start getting fragile the farther up you get that test pyramid. If you've got control of the device and you can say, always open it in this browser, things become a little more bearable. But when you're running it on someone else's infrastructure, this is what kind of the stuff you have to deal with.
But at least the Samsung is consistent across all their devices, right?
I need another beer.
I think also when you are playing through Google Play,
Come on, go ahead.
I think you can, I mean, it runs the default if you don't give it any tests. I think you can give it a list of automation tests to run. A list of types.
I'm not sure. They give you another option where you can basically say, here's my application, and there's a tool called Monkey Runner, and they'll submit it across a handful of devices and just kind of randomly execute different things, button pushes and screen orientation changes and turning the power on and off, and just to see what your application does. It's entertaining to watch. You can run it locally. You can find some interesting bugs, especially with like timing things or timing or lifecycle things. If you have a login screen in your application, it's not going to make it very far. It's going to figure out how to log you out of the application in about 8 seconds and then just get stuck because it's not going to be able to put in the credentials to get past it. So it's an interesting tool, but yeah.
Ours always seems to find the reset password.
Yep.
But it gets stuck at the capture part. So
Yep. Yep. I can see that. So they've got a mix of physical and virtual devices. When you're running these, you can set up your own configurations. Sometimes they'll work, sometimes they won't. It depends on what day of the week it is and what they've just pushed out to their thing. It's definitely still beta software. It's valuable. It's a paid service, so if you don't have a Galaxy S6 and you want to see if your application runs across it, write an automated test around it to see if you can get through the happy path, and push it up to their stuff and pay the 20 cents. And
So there's a warehouse of phones plugged into servers running your app somewhere.
I imagine they've got a data center, with racks with USB cables all spidering out of it. That
It's not just a bunch of your closets back there?
it's a distributed data center.
I think it would be cool to write an application that turns on the camera so that you can see what's going on.
This is how Duo got started, I think.
Is this how what?
This is, I think, how Duo got started. So you can just go to firebase.google.com to get signed up. You have to change it to the Blaze pay-as-you-go plan, and then we saw how to run it in Android Studio. And is it still running, or did it finish? Okay, so it finally finished. And how long did it say it took to run? It took a lot more than 16 seconds. Okay, it doesn't say how long it took, but sometime between when I started this and now, it finished up.
Does that give you a link to the result?
As the dashboard, the results are up top, they've got a link for that, so you can see it in the console. Yep. And this probably took 15 or 20 cents to run. So, did our live coding? It all worked. Yay. Resources. I mentioned earlier there's a lot of good documentation on the developer site, and it's getting better all the time. They've really invested in this in the last year. It's worth checking out. Off of this, they've also have projects where they have kind of like an Android testing samples. So if you want to see more complex or advanced usages of some of these things, they've got actual demo code that you can go and look. It's like, oh, okay, I didn't know you could do this, or how do I write an Espresso test against a recycler view? If you haven't heard about Caster.io, it's a really great site that has very easily approachable videos for learning how to do some of these things, kind of broken down into small bite-sized chunks. It's a paid service, but totally worth it if you're doing Android development. And if you want to see how to pull in all these different projects, you don't have to do all the Gradle manipulation and the weird config hacks. We do keep a starter project that we use internally up on GitHub that's public. So we try to keep it up to date with what works and what doesn't, along with all the other libraries. So feel free to look at that. And that's all I have. I'm on Twitter and GitHub and here and Slack, and you can usually find me someplace to harass me. Any questions? Jason?
I think Chuki Chan has a really good espresso, intro to espresso.
Yep.
I don't know if it's on Casper.
She gave one, or Chuki Chan gave one at the Big End Barbecue back in this last October on some more advanced espresso stuff. That's really good. And she started publishing some new things to Caster recently. So she's got a lot of really good things on espresso. Jason?
So you had mentioned that JUnit and the Roboelectric. Is there any point in writing any unit tests in JUnit if it's limited to the fact of not being able to use any of the Android APIs? Do you just write everything with Roboelectric? Or is there a benefit to having your unit tests written in both? Ones that don't use the APIs to just write JUnit, and then the ones that do in Roboelectric?
It depends. If you're doing a lot of things that integrate with, like you can't really avoid context in Android applications or resources or things like that. As soon as your code touches those for some behavior, like let's say maybe you're internationalizing something, Roboelectric is huge. If you're pulling in things like the text doodles, where there wouldn't be a reason to not use it, Roboelectric kind of makes sense. I think that if you at least have one test that loads it up, they all can leverage it. I can't say that for certain. And then for anything else where it's actually doing more device integration, I'd look at a tool like Makito if you really want to write unit tests to kind of fake out behaviors, or start moving into the instrumented tests, the higher level things that are actually going to run it to exercise a real component.
Yeah, our way of doing it is we try to mock it up with Keto, unless it's just going to take a lot of work or if it's going to be not worth anything, and then we use Roboelectric. Keto is way faster than Roboelectric.
Yep. Any other questions? Cool. Excellent.
Firebase is so cool.
Yep. I kept it, I think, to an hour, so I'm going to stop here and we can hang out for a while. Feel free to finish up the food, chat with everyone for a little bit, and then if you're interested later, we'll head to Rusty Bucket. I'll be there at least, and I think that probably a few others are going to go too. So thanks for coming out and listening to me, and I hope that this was useful for you. Cool. Thanks.